Hi everybody, and thank you for coming to my talk. My name is Martin Petrulak, it's from Eastern Europe, whatever, and I will be talking today about unit testing. Just a little bit about myself. So I'm basically doing Android since 2011 or 12, I think. In the beginning, I was working as an indie developer. I had few apps that were providing basically the live scores for users for soccer, and like during this period, I didn't write any tests because I was basically writing features. Then after some 3 years, I think Google banned my apps because of the copyright issues. So I had to find a job. So I was working for a few early startups. And in these startups also, like we had to write features and no tests. So at this point, I was also not writing any tests. And recently, I've been working for bigger companies, and here we have to write tests because we have to write the tests. So I will tell you a little bit about this. Before we start, I would like to ask you, who is writing tests? All right. JUnit test, JUnit 4 tests? 5? Is there anyone who is using Spek? So you can then ask me some tricky questions. All right. So what we're going to do today, we will just talk about some sort of drawbacks of JUnit or what can be kind of improved, and we will have some short introduction of Spek. We will go through project setup and some core principles, and then we will discover two distinct styles, how we can write our tests, and then there will be some wrap-up and questions. Is there anyone who is not familiar with Kotlin? All right. Is there anyone from Poland? Cool. Then you might understand. Shit. The audio is not playing.
Tyle na kanapce. Tyle na burgerku. A tyle na żeberkach. O, a na szaszłyczku jeszcze więcej. Nie ma konserwantów, nie ma ograniczeń. Jesz tyle, ile się zmieści. Kotlin. I love ketchup.
So that's Kotlin, for those of you who don't know. And let's go to the stuff. So, I mean, this is just some imaginary test that I wrote, and I guess many of you have seen something like this. So you have basically, we are, let's say, testing some registration function that can behave in 3 different ways. And what we usually do is like we write this super long function name, for example, should throw an exception while registration when the user name is invalid. And then we have more of these functions there. So like we are reading code for like 90% of our time, I think. I read it somewhere, I don't know where. So this is maybe not the best how we can do it. The other problem here is like we are actually using comments, as you can see in this last example, to give our test some sort of structure. So we are using given and when then comments to do this. Yes, let's think about some better solution. So let's imagine that we can write something like this. So basically, on the top, we can basically describe what we are testing. So we are testing registration function that can behave in 3 different ways. Those are these conditions, and then we have some assertions that we want to check. So this could be something maybe easier to understand and also to review. The second kind of problem can be that, like in our production code, we are often striving for perfection. We are trying to keep our code dry. We don't want to repeat the code. But often in tests, we don't care. We just copy paste, whatever. No one cares. Those are the tests from retrofit. So as we can see, we have this copy paste code for retrofit and example, and they are doing this because they want to keep their test isolated. That means that test A is not affecting test B, and this is the way how they did it. So let's imagine that we have some other way how to do it. Let's say we have some magic initializer delegate that can basically create a new instance of a property for us for every test, and then we can just do some tests. Parameterized tests, so I mean, that's some simple example. So we have some enum and some function that takes string input and does some transformation. I think in JUnit you have to write a bunch of annotations and some code that I didn't include here, but let's just imagine that you don't have to write any annotations and you can basically just test it as your production code. So you could write something like this. You create some list of inputs and outputs, then you iterate over this list, and then you basically perform some assertion. If you like these ideas, I'm happy to tell you that the Spek can do all of this. So let's jump to Spek. So it's obviously a unit testing framework. It provides us with DSL that allows us to write this nesting. It uses JUnit 5 engine underhood to run the tests. You can use it for backend, for Android, or multi-platform, or whatever you want. Not whatever you want, for those things. It's also compatible with Jacoco, so you can generate your code coverage. It doesn't force you to use any assertions or mocking libraries. You can use whatever you want. It's been around since 2012. That was the first commit by Hadi Hariri. He was working for JetBrains, so it started like some JetBrains hobby project, but there was some other person who was working on the same stuff, so they just merged, and now this other person is the main maintainer of the repository. And there are two distinct styles of how to write the tests, but we will get through that later. All right, so if we want to include Spek in our project, this is the top level Gradle file. We basically have to add JUnit 5 dependency because Android is not supporting this out of the box. And we also have to add the Maven repository where we get Spek from. Then in our module, we just have to apply some plugin, do some stuff. You can find this in documentation and add some dependencies. So how do we create a test? So basically we are creating objects, and these objects are extending Spek class, and this Spek class has one parameter which is the body, where we are basically putting all of our code. And what we can put inside is either test or group. Test is a function where we are putting assertions. You can't put anything, you can't nest anything else inside. And group can nest multiple subgroups or tests. So if we now have a look at some super simple test, let's say we are testing some registration. We are extending the Spek object, Spek class, and we have a group called registration. So this means like, okay, we are trying to test the registration scenario. We have some tests. First one should initialize with default values. So let's say there are some defaults that we want to check, so we can put it here. And then we have some two ways how this function can behave. It either succeeds or fails. And those are these two scenarios. When we now run the test, we will see something like this in Android Studio or IntelliJ. Execution order. All right, so let's just make this a little bit nicer. So we are adding this print statement to our tests. When we now run the test, we will see something like this in console. That's obvious. Okay, let's make it a little bit more complicated. Let's add print statements to the body of each of the group that we have. So we have basically 3 print statements. First one is in the top, and then all, like both nested subgroups have one print statement. When we now run the code, who thinks the output will be the first thing? That's this. Okay, nobody's thinking, very good. Who thinks is the second one? All right, and the last one? Okay, so it's the second one. And why is this? So it's because there are basically two parts or two phases when we are executing the tests. First one is discovery, when the Spek framework goes through our test scenario and it creates the test tree. And it also executes all the code in the groups. So that's why we could see these print statements from the groups. And the second phase is execution of registered fixtures for scopes. That's what we will get to next. So that's basically place where you want to set up or tear down your test case, and then the tests, which are the assertions. Fixtures. So often we want to set up some test case, we want to open database, then we have to close it, we don't want to leak memory, or we want to perform some operation on our system under the test. And for this, we have basically two places where we can put our stuff. So we have before or after group, which is executed in the current scope only once. Or we have before and after each test, which is then executed for all current and nested scopes. And this is, yes, this is the place where we define our mocking rules and where we trigger the test case. All right. So let's enhance. Can you actually see it? Also from the back, somehow? Okay. So we are now adding these fixtures into our pseudocode. So we have one before group, and then we have a before each test in a first subgroup, and then after each test in a second subgroup. When we now run the test, we will see following output. So we can see before group that is executed only once. Then we can see test 1. And then we can see before each test success. That's the before each test fixture in the first group. Then execution of the first test. And again, before each test, and then test, and so on. And then at the end, we can see the last test and after each test. Just to demonstrate that this before and after test executes also for the nested scopes, we can add this fixture to the top level. And if we now run the test, we can see this super polluted output. And you can actually see that before each test root is executed 4 times because we have 4 tests. So this is, so we know how to do the nesting. That's good. But we often need a lot of bunch of properties, some mocks and system after the test, under the test, and whatever else. So let's have a look how we can declare properties. So as we could see on previous slide, how retrofit guys were doing it, they were basically declaring or copy pasting some code in every test because they wanted to keep this isolation rule. So let's have a look at this pseudocode. So basically we want to create some property that is then unique for every test. So when we now run this test, we will see this output, which is bad because we are basically sharing the same instance of the object across all of the tests. So that's not what we want. Let's have a look at this. So this is some other approach. We can create this, we can use a late init variable and then use before each test fixture to initialize property before every test. So when we now execute this, we can see that we have a new instance of property for every test, which is good. But it's kind of ugly because we have 4 lines of code for one property. But there is also other option how to do this, and we can basically use memo as delegate that comes from Spek framework. And when we now run this, we will see something like this. And that's good because basically we are getting a new instance of mock for every test. All right. So this is the memo as delegate. Sometimes you want to share some property. Let's say you have some tests that are somehow dependent. So first test is mutating some property, and then the second test is doing something with this mutated property. So you can actually define the caching mode, which means like how long is this property going to live. By default, this is test. So each test has a new property, new instance of that property. There is each group. That means that we will get new instance per group, or scope, which means we will have the same instance in the current scope and all the nested scopes and subgroups. That's like if we just define some property like la 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 equals string, whatever. So that's nothing special. And then there is also this inherit, which I don't know what that is. Parameterized test. So when we want to write parameterized test, we can write it like this. So we are just creating some object again. We are extending the spec. We are defining the group, and we are saying, okay, we want to test the transform function. We are creating an input and output, and then we are iterating over the data and performing the assertion. Yes. When we now run it, we could see something like this. This is what you will see. So I made it wrong by purpose, so that's how it looks. Okay, so how do we run the test? So if you are hardcore, you can just use terminal and play with it. If you are not hardcore, you might want to install plugin. It's much easier and better. There are two plugins. One is for Android Studio, and second one is for IntelliJ. Don't mix it because it will not work, and then you will end up like Googling for maybe half an hour or hour and swearing why is Spek not working. So you have to, if you are using Android Studio, you should get that one. And if you are using IntelliJ, you have to get the other one. All right. So when we install this plugin and restart Android Studio, we will see something like this. So we have these green triangles. And when we click on it, we can actually run the tests or groups, or yeah, basically we have a lot of flexibility how to run our tests. Okay, so we know how to run it. So now let's jump into specification style. So in this style, we are now not longer using group and it and test, but group translates to described or context, and test translates to it. So let's imagine we have some class, some repository. It has 5 methods, and each of these methods can behave in 5 or 3 or whatever, how many ways. So how we were using it at my last project was like we created some test. We called it repository test. We extended this spec object, and then we said, okay, describe. And we use the name of the function. So for example, when we were testing repository that was handling user interaction, we used described, and then we set registration, and then this registration, this describe block was holding 3 or 4 contexts, and in each of the contexts we said registration failed, or username is invalid, or whatever. Before and after each test, you can still use it, or you can use before each or after each. That's just some aliases that we have, and the same goes for groups, so we can just use before or after. Let's have a look at some test. This is in my sample repository, so you can then just later check it out if you want. So we have a bunch of, so what we are testing here is, that's what I said, we have some repository, and that repository, this repository is basically playing with local and remote source. Local source is some database or some persistence, remote source is API that talks to API. And then we have this repository has method called refresh, and what this is doing, it's like we are hitting API, we are getting some Bitcoin price or whatever, and then we are storing these values in our persistence. So how we can structure it, like we have this describe block on the top. We are saying, okay, we are testing refresh function, and then we have first way how this method can behave, which is, like, even I can't read it. New values are fetched from API, and updating local source is successful. Woohoo. Then we have before each. That means like we want to execute this code before every test. And by test, there are these 2 it blocks. It should store new values, and it should complete. So, and then there is the second context. New values are fetched from API, and updating local source is not successful. So that's so bad. And again, we have some before each test struct and then some assertions in it blocks. When we now run it, we can see something like this. Everything is nicely nested and everything is green. Life is good. All right. Okay. So yes, we want to keep it dry. We don't want to repeat ourselves, but we have something like this, which means basically we are defining default behavior for this remote source. And what we are saying here is like, okay, if we are getting prices from remote source, just return us some object. This can be also easily simplified, and we can basically provide this rule in the definition of our mock property. And then this line of code is not present in the before each struct. If we want to override this behavior, we can just override it in before each struct again. So if you want to have some negative scenario, if you want to fail this, if you want to throw an error, we can just do it easily like this. Okay. Sometimes you want to skip some tests because they are failing or whatever. So that's super simple. You can just add x prefix, and it works for it, describer context for everything, blah blah. And now when we run this test, we could see something like this. So basically first test is ignored, and also last describe block is ignored. And we can also see it nicely in the output. When we have a look at the definition of the function, it has basically three parameters. First one is the name. Second one is the skip parameter that is set to no by default, and then there is a body. So if we want to do something let's say more fancy, and we want to exclude some tests depending on the build, for example, we can just do something like this. We create some skip parameter and we say, okay, if this is a debug build, we don't want to perform these tests. And then we provide this skip parameter to test. Yes, and you can do this for test or describe or context, bless you. When we run it, we can see the following output. Okay. Okay, and yes, we can also see that. Gherkin. Is anybody familiar with Gherkin? Very good. So it's just some sort of written text that should look like some executable specification. There is a bunch of sentences, and most of these sentences start with a keyword like given, when, then, or feature or scenario. They're also translated to multiple languages, but I guess everyone is using just English. Here is some example. You can read it if you want, but you don't have to. All right, I just have a sip of this. Okay. So now let's have a look at our spec stuff. So we have group and test. So basically group is being translated to feature or scenario, and then test is being translated to given, when, and then. So let's now have a look at the same test case with this repository, Bitcoin repository. So basically we have some feature which is called refresh. So we are testing refresh feature. And then we have some scenario which is new values are fetched from API, and then there is something else like API throws an error. And inside of these scenarios, we are using given, when, and, then, and you can see it there. And when we now run this, we will see something like this, which is not so cool because we have this polluted output, and code that is in given and when appears like test, but it's not. And if somebody likes to have a if somebody thinks like the more tests you have, the better life is, you will get some arbitrary tests. So if you are that person, you should use this, and you will get some extra tests for free. Let's now have a look and explore why that is happening. So let's just use our print friend again, and when we now run the test, we can see, bam, that we are basically, this means that we are interacting with the same instance of the property, which is kind of breaking this isolation rule, because test in, for example, in this then clause is then interfering with this other test that is in and clause. But that's how it works. Let's say we want to test something else, so we are testing refresh, and then we also want to test login. So what we will need to do is that we have to basically extract all of our properties, like remote source, local source, outside of the feature, because that's how we can share it. When we now run it, we will see something like this. Doesn't work. So it doesn't work because default caching mode is a test. And that means, like, if we are defining our properties in this way, we are getting new instance of that property in every fixture there. So there is new instance in when, there is new instance in then, and then there is new instance in end. And that's why it's not working. If you want to make it work, okay, that's the output. If you want to make it work, we basically have to define the caching mode. So we have to say, okay, all of these properties, they should live in the group scope. Okay, and now when we run the tests now, we can see that everything is green and nice. That's how we like it. When we want to, I did it by purpose, so I want to fail the test. And this is what I see. So the bad thing about Gherkin is, like, if some of the test is failing, none of the tests underneath are being executed. So if you have 20 tests and 5 of them are failing, you have to go one by one to see all the time what's failing. So you can't fix all the failing tests at once. So there are some disadvantages. It's not so flexible with nesting because we have to basically follow this feature scenario template, kind of. We can't have scenario nested in scenario or do anything more. Caching mode is scope, which is kind of breaking this isolation rule, but it's fine if you know what you're doing. There is no built-in mechanism for skipping, so you have to build something on your own, and then given and when acts as a test in the test count, which is also maybe not so nice. On the bright side, it looks nice, and it's also easy to understand by everybody, basically. So to wrap up, that's what I think. Like, nested tests are easy to read. That means it's easy to understand what we are doing. That means it's easy to review. Reusability is very easy with the memorize delegate, so you don't have to do a lot of copy-paste. You can write this parameterized test very nicely, and just as you are writing your production code. On the other hand, there are not so many options to fine-tune stuff. Like in JUnit, you can do a lot of stuff there, basically. Then you have these two styles. You can decide if you like some, and you can give it a shot. And also, they can coexist on the side of your existing JUnit test, so you can play around if you want. So it's not so hard to try it out. Some advices, best practices. Use print, because if you will try it out, you will always find some issues. There are issues with the executions. There are issues with this with properties. Sometimes you are mutating something that you don't want. So print is always good. And then, yes, never do anything with your properties outside of before or after because of this execution order. If you are if you are trying to trigger the test scenario in the group body, it will not behave properly. You should usually put one assertion per test. So you, like if you have some method that is doing 5 things like opening new screen, sending analytics, and changing something in the database, use 3 different test or it blocks. And of course, like use test only for assertions. You can also write something like this. This will work, but that's not how it should look like. Resources. So there are some things online. First one is Spek framework.org, where you can find some documentation. Second one is the Git repository. Then there is something about Gherkin. Here you can find some sample tests that I made. I will later publish slides. I mean link to slides. And yeah, it's the company I work for. We do projects for different clients, and that's it. So thank you very much, and I'm open to questions. And if you have questions, I was instructed that it's good if you go there to the mic and then there in the middle.